All right, well, happy Friday. We'll get started. Let me switch over into my folder here. Let's see. Okay, so we're on Jupyter Lab. I believe I made a push late last night. So you should be able to do git pull upstream main, and that should pull lecture 2-3, and we will cover flow control. All right, so on Wednesday we talked about functions and scoping rules and things like that, and today we will delve a little bit more into Python stuff, and we will talk about kind of flow control using conditionals. I don't know. Okay, sure, got it. All right. Flow control using conditionals and things like that. So, one of the most kind of basic things that you have to have is a conditional statement where you have something like if. Okay, and so we have if, and we have the else if, which in Python is elif, and finally else. And I think we're all familiar with how this works, but we'll just kind of go through this. Now, a couple things about conditional statements in Python is that, one, you don't need to use parentheses. You just kind of type it out. You just say if, say x equals 0 or something like that, right? The double equals is for a test of equality. Single equals is for assignment. So just make sure you don't mix that up. You use a colon to end a conditional statement, and then you have to use indentation. Python very much relies on indentation to figure out which lines do what, and so the lines that are indented after the colon are associated with the if statement, and when there is no longer indentation, the lines are no longer associated with that if statement. Okay? If you are going to use something like elif and else, those statements have to be on the same level of indentation as the first if statement, okay? And if you have like nested conditionals and things like that, you have to be aware of your levels of indentation. I believe in Jupyter, when you hit tab for indentation, or after you hit a colon, after you type in a colon and you hit enter, it automatically indents for you. And when you hit tab, it automatically inserts 4 spaces, okay? And so that kind of, so you can hit space 4 times. There's always kind of this slight debate of tabs versus spaces, but I guess Jupyter kind of solves that by whenever you hit tab, it's not actually inserting a tab symbol, it's actually inserting 4 spaces for you. Which is probably, I don't know, I would say cleaner. All right, so anyway, here, for my kernel, I'm gonna just restart and clear all of my outputs, and let's take a look. Okay, so our first one, I've got x, I assign the value -3 to the variable x. We're gonna just test a run of this very simple thing. Test to see if x is equal to 0. If it is, we print x as 0. If x is greater than 0, we will print x is positive, and if not, then we write x must be negative. And so running through this, we end up with -3 must be negative. Okay, just like any other language, the else if and the else only get executed if the if statement prior to it is negative. Okay, so here I've got x equal to 100, and I write if x is greater than 0, print x is positive. This statement, else if x greater than 3, this will never get executed because there's no situation where x is greater than 3, yet the previous if statement is false. Okay, so this is only going to get considered when this if statement is false, and there's no situation where this is true but this is false. And so when you have something like x equal to 100, it's just going to run this. It's going to evaluate this to be true, and it nets 100 is positive. Okay, so no problem there. You can nest conditionals like this, and you can do that. But you know, nested conditionals, they're tough to read, all right? And one of the goals that you should always have in the back of your mind is, am I going to have trouble reading this later? and if the answer is yes, I might have trouble reading this later, don't do it, okay? Try to think of a way that's going to keep it easier to read. So you could do, if 0 is less than x and if x is less than 10, then print x is a positive single digit number. That's fine, this will work, and we can say, you know, 5 is a positive single digit number. That works. An alternative that I would say is better, okay, is to use something like an AND statement. Okay, so you can use AND statements or statements with your conditionals. And so, you know, here I've got, if 0 is less than x and x is less than 10, then that's what's going to happen there. And if you have something kind of like this, you know, is x between this, and this, you can actually just kind of combine the math statement like this. And Python is smart enough to understand a statement like this, which is also nice. So all of these things work out just fine. Okay. All right. Recursion. Recursion is one of those topics that I feel like every programming class covers a little bit, but then it's a little bit of a weird thing and can cause confusion. And so recursion, you are calling the function from within itself. When you write a recursion function, you always need a base case so that it exits, okay, and doesn't where it doesn't call itself, all right, and that prevents it from running forever. So here we write a function called define, called countdown. So we write define a function called countdown. It's going to take into as its input argument some value n, and basically the base case is when n is less than or equal to 0, we're going to just print out the word blast off, and that's going to be the end of the function. Okay, but if it's anything other than 0, we're going to print out whatever n is. Okay, and then we will call countdown again, this time on a reduced case, which is going to be n minus 1. And so if I start off with 3, then basically the execution is going to be, it's going to print 3, then it's going to call countdown on 2. Then when we call countdown on 2, now it runs with countdown 2. This is false, so it prints 2, and then it calls countdown on 1. Then when we call countdown on 1, it evaluates this. This is false, so it prints out 1, and it calls countdown on 0. And then when it calls countdown on 0, then finally we hit our base case. We're going to print out blast off, and that function returns and ends. And now we go back, and the countdown that called 1, n equal to 1, returns nothing, and then n2 returns and n3 returns. So all of these things kind of return, so on and so forth. So we'll run that, and so here with 3, countdown 3, we get 3, 2, 1, blast off. There's just other kinds of examples here. So here's another recursive function, and we can say print some string s, and we're going to do it n times, okay? And so here the base case is when n is equal to 0, the function will quit. We do return none, and then prior to that we will print out the statement s, and then we call a reduced form of recursively reduced form of print n. We'll call it on s using n minus 1, and so here it will print out the word hello 3 times. If I say, you know, print it 0 times, it just returns nothing. One, I'll print it once, or so on and so forth. Okay. Factorial is also a function that works well with recursion. because you can think of 4 factorial as the same as 4 times 3 factorial, 3 factorial is the same as 3 times 2 factorial, and so on and so forth. And your base case is that 0 factorial is 1, okay? And so we'll have factorial n. We are going to return, when n is 0, we're going to return 1. Otherwise, return n times factorial n minus 1. And so, so when we start off with factorial 4, we're going to do 4 times whatever factorial of 3 returns, which will then be 3 times 2 factorial times, so on and so forth. And so when we do that, we get exactly what we expect. 4 factorial is 24. 5 factorial is 120. So, so that's recursion. And technically, you can just have recursion, and you don't actually need to have for loops or anything like that. So it's technically possible to accomplish all forms of repetition with recursion only, but it's kind of frustrating to have to use a language where the only form of repetition is recursion. I think Lisp is one of those things, or it's annoying. So you can also achieve repetition in Python using things like loops, and kind of the most basic loop type is the for loop, and that's just going to repeat your whatever the lines of code that you have for every value that you have within an iterable. Okay, we have several kinds of data structures like lists, tuples, ranges, and strings, which Python considers to be iterables, and we'll cover each of these things in more detail. Let me go ahead, before I do this, let me give you your first view quiz answer, which is the letter D. D as in dog. D as in dog. All right, so here I'm going to create a list. This list has the values 5, 7, 2, and 1. We're going to call that values, and then we'll say y. We'll start off with y equal to 0, and then I'm going to run this for loop where for each value within, for each, I guess, x, each number x inside this list of values, we will print out the x. Then I will add x to y. So I can do y plus equals x. This is the same thing as just writing y is equal to y plus x, and then we will print out y. So first it will run with 5. We'll print out 5. We'll add 5 to 0 and update the value of y, and it will say the running sum is 5. Then we'll print out 7, and then we'll add 7 to y, which is now going to be 12, and I'll say the running sum is 12. And we add 2, and we'll get 14, and then we add 1, and we get 15. And so this is what we get, 5, and so on and so forth. So it's just kind of running this and this. Then once it executes it for 5 and reaches the end of that code block, it goes back to the start with the next value or next x value in the list of values there. Okay. Python treats strings as iterables. You can think of a string almost like a list of characters. And so if you say something like for a in this string UCLA space UCLA, it's going to go through each character in here, and what we asked is take that character, make it uppercase, append on an exclamation point. And so this is, I guess the cheering section at a game, and so you get UCLA. And I guess this is just, there's that one downbeat where you just, I don't know, whatever. Okay, so you have that. Okay, range object is another iterable, which is handy if you just need like a sequence of numbers, okay? So writing something like range 10 is similar to going to R and typing in 0:9, okay? It's going to create a range of indices that is 10 items long. So range 10, it'll be 10 items long. Python always starts off at 0, so range 10 goes 0 through 9. Range 100 is going to be 0 through 99, so on and so forth. You could also make it a little bit more complex. You can have a range and provide up to 3 arguments, a start value, an end value, and a step size. Okay? So, so if you do this and you type range 10, what you get back is a range object. Here you get range 0, 10, and that's, again, 0 through 9. And so one thing about Python is that it is what we call lazy, all right? In that it only asks your computer to do computations when it needs to do it. So you could do something like range 1 billion, okay? And Python will just say, hey, this is a range object going from 0 to 1 billion, but it's not actually going to write out the numbers 0, 1, 2, 3, all the way up to 1 billion. Whereas in R, if you said something like 0:1 billion, okay, it's gonna write every single one of those numbers, and it might take, I mean, it's gonna be quick, but it'll take like a couple of seconds to do this, or a fraction of a second to do it. But it uses all of those clock cycles to do that thing. Whereas with Python, it just says, oh, okay, I get it. These are, you want the numbers 0 through 1 billion, and I will give you those numbers when you actually need them. But for now, I'm not going to bother writing all of this out. Okay? So it just stores this as a range 0, 10 set of instructions that says, okay, I will give you the numbers when you need it. Okay? And so, for example, here's when I need it. I'm going to say for I in range 10, print out I, and then end space here just says don't create a new line. The default is after it prints something, it goes to the next line. Here we're just going to say do a thing. And so as it runs, it's going to print out 0. Then it goes to the next thing, and it says, okay, what was the next thing you wanted? It's a 1. What's the next thing you wanted? 2, 3, and then it prints out 0 through 9 like that. Okay. Range 5, 10 starts at 5, goes up to, but doesn't include 10. And again, it's lazy, so you just get back this range object with instructions that says start at 5, go up to, but and stop at 10. If you wrap the range in a list object, then Python goes, okay, I will give you all of the numbers, right? So if you say, hey, I want all of these things and I want you to put it in a list, then you can do that and you'll get all of the numbers 5, 6, 7, 8, 9. So this forces Python to evaluate it. Okay, so again, Python's lazy. It doesn't want to do it until you force it to, and then you say, hey, I'm forcing you to list all of these things out, and so then it does it. Okay. Here I have a step size of 2, range 0 through 20. So it's going to start off at 0, and it goes up to, but stops at the last number here is going to be 18. Okay. So so there we have that. If you put in 21, then it will go up to 20 as far as end. Okay. If you put in something like 20.1, Python gets upset with you. Okay. It says I don't, the range only accepts integers as arguments for the start and end. Okay. You can also specify negative steps, and this will kind of go backwards. So 10, 5 starts off at 10, goes down to 9876, right? If you don't specify a negative step size and you say start at 10, end at 5, Python's going to go, I can't do that, and you end up getting an empty. There's no values. No values get returned by that. Okay, so this is just kind of the range object, which is very, very commonly used inside, I'd say, for loops, or anytime you kind of just need a bunch of these values created. Another type of loop we can run is the while loop. Okay, and while loop will just run whatever lines of code you have until this condition is false. So you have this conditional statement. So basically, while this conditional statement is true, run these lines of code, keep repeating it, and when this condition becomes false, then stop. So we'll start off at 0. Here I'm gonna, while I is less than 10, print out I, and then increment I by 1. And so where will this end? We will start off at 0, and then it gets, what's the last number it's going to print? 9, 10, 11? What do you get? So the last thing that's going to print out is 9, okay? And if I ask what is the value of I after this loop runs, finishes running, what is the value of I? The value of I is 10, okay? Because what happened is we printed out the 9, we updated I to be 10, and then we go back to the top of the loop, we evaluate the condition while I is less than 10. Now I is 10, and so this 10 less than 10 becomes false, and so we quit. And that's what happened there. We have these keywords that guide our usage of for loops or while loops or any kind of loops as well. Okay, the break statement quits out of the loop entirely. I guess innermost loop that's running if you have nested loops. And then the continue statement skips the remainder of the current loop and goes to the next iteration. So here I have a for loop, and we're going to do for n in range 20. So that's equivalent to 0 through 19. All right. And we have this conditional. We're going to evaluate if n mod 2 is equal to 0. So n mod 2 is just a way to check to see if it's even. Basically, if n divided by 2's remainder is equal to 0, then continue. If we don't encounter this continue statement, then we will run the last line, print n. Okay. So when we hit the continue statement, if this does get evaluated, which is only evaluated when this conditional statement is true, then we go to the next iteration there, right? So so what are we going to get printed out when we run this? So we start, what is the first value that's going to get printed out here? So remember, our range object evaluates from 0 to 19. The first value is going to be what? 1, right? Because the 0 hits the continue, so it never prints out when n is equal to 0. So then we get 1, n is 1. This is false. It's not going to evaluate continue, so it'll evaluate this print statement n, okay? And it goes to the next thing. N is going to be 2. When n is 2, this is true, and it hits the continue. And so when it does that, it doesn't run print n. So we're going to basically get all of the odd numbers 1 through 19. Yes, question?
So continue, does it just skip the break one?
Yeah, continue. As soon as Python reads a continue, it goes to the next iteration of the loop. So so when it evaluates continue, so when n is an even number, it's going to evaluate this statement. When it evaluates continue, it skips any other code that comes after it, right? So what, here I just have one line of code, this print n statement. But even if you had like hundreds of lines of code, it skips everything else and just goes to the next iteration of the loop. Yeah. All right. There's a billion ways to write something to evaluate or calculate Fibonacci numbers, right? Fibonacci numbers is you take the previous two numbers and add them together. So 1 and 1 make 2, 1 and 2 make 3, 2 and 3 make 5, 3 and 5 make 8, so on and so forth. We can take advantage of Python's tuple unpacking and tuple assignment. And so I can say, hey, I've got 0 and 1, and let's assign that to A and B, all right? And we're going to have a max value. Here I'm going to create a while loop. This is going to be while true. While true will run forever, okay? While true is going to run forever. So the only way you can quit out of a while true is including a break statement, okay? Whenever it encounters a break statement, that will quit out whatever the loop is. So here we're going to just say, repeat this forever until you hit a break statement, and that's going to be A and B, okay, take our current value of B, make that equal to A, and then add A and B together and make that your new value of B. So basically we're just taking our kind of two previous values and evaluating that. Yeah, question?
Is that any different than just starting this with while A is less than or equal to A max?
Effectively, it is not. This is just to illustrate the use of break, okay? Yes, absolutely. Probably just writing while A is less than A max, okay? Would yield similar results, okay? But just to kind of illustrate here, this is an example where we can use break, okay? And so it's going to keep kind of do tuple unpacking here and do this. I'm sorry, guys. I got to ask you guys to stop whispering back there, please. All right? Thank you. So we'll do that, and as we continue, we will append all of our values of A into this list L. Okay, so we'll do L.append A, and that's going to store results into L. So we'll go ahead and run this, and we'll get kind of our Fibonacci numbers, right? So we get 1, 1, 2, 3, so on and so forth, up to 89. Okay, these are all different ways to get oh, we have a question. Yes.
When you're doing two-one piping, when it's changing the value of B to A plus B, is it like the value of A that's already been changed to B, or is it?
This gets evaluated simultaneously. So it's not first B goes to A, and then we're gonna, like if this is 5, it's not gonna first do, like, so this is one of the beautiful things about Python, right? Because if I did this, A is equal to B, and then B is equal to A plus B, right? Which looks like what we're doing here. This is not going to work because first this is going to get evaluated, and then this thing is now going to basically just be 2 times B, okay? So that's not going to work, okay? But with Python, this gets evaluated simultaneously. So within kind of Python's memory, it evaluates, it calculates what this should be, and it calculates what this should be, and then it assigns them at the same time. So it's going to get B, and it's going to do A and B, and then assign both of these things at the same time, rather than in this sequential thing. Because if you did it sequentially, then you run into these issues. Was that what you were asking?
Yeah.
Okay, yeah. So this is a really, really nice feature of Python in that you can do kind of simultaneous assignment of these things, and you can have like a big tuple, and it's like all of these things get evaluated at the same time and get assigned at the same time, rather than this sequential thing, which sometimes as you're working, you go, I don't want that to happen. Okay. I think this is really straightforward, right? All of these things, right? 5 equals 5, that's going to be true. 5 equal to 6, that's false. 5 not equal to 6, that's true. 5 greater than 6, false. 5 less than 6, true. 5 greater than or equal to 6 is false, and 5 less than or equal to 6 is true. So these are all just different, these are the kinds of conditional statements you can put into an if statement or a while statement or something like that. Here, I've got string 5. Is that the same as integer 5? That's going to be false, okay? And we often don't think about it as much here, but we've got these, you can compare strings, and it's kind of like comparing things in alphabetical order, okay? So when we say string A, capital A, less than string B, we're asking, does that come before the other in the alphabet, right? So does A come before B in alphabetical order? The weird kind of thing is that all uppercase letters come before all lowercase letters. So capital Z, I guess you have all caps A through Z coming before lowercase a through Z. So it's not quite alphabetical because how does that work? Normally in English, it's alphabetizing a list is not case sensitive, but in Python it is, okay? Obviously lowercase a is going to be lowercase e. Okay. If you have multiple kind of things that evaluate your and, you have your and statements and your or statements and not statements. And so here I've written true, and this would be silly to actually do in Python. But whenever you see the true, just imagine one of these conditional statements, right? So you have like, if x is less than or equal to 6 and y is equal to 7 or something like equals 7 or something like that. And I think all of these, we're familiar with how logical operators work. So you have true and false is false, true or false is true, and then you got the opposite, not true, not false. All right, what is false or not false? What's that? That's going to be true. True and not false? Also true. Okay, this is like, all right. You have, I don't know, Python idioms or just programming idioms in general. X mod y equal to 0 is just, is it divisible by y? So here we've got like, is something divisible by 2 and is it divisible by 3? So n is 6, that's going to be true. Is when n is 8, is it divisible by 2 and 3? That's false. Okay, but we could say, hey, is 8 divisible by 2 or is it divisible by 3? Then we get true. Okay. Let's talk a little bit about some strategies when it comes to writing functions. When this is true for any language. When you start writing a function, don't start by writing define function, okay? Because every time you do that, it's going to create a function, and just remember within Python, when you have a function running, anything that runs inside the function, all of the variables created, only exist inside that function, and they disappear as soon as the function stops running. So like if something goes wrong, you can't go back and say, hey, what was the value of x when it broke? What was the value of y when it broke, right? Whereas if you start off, kind of the general strategy is just write a code block in your global environment first, okay? Write a code block that does what you want it to do. Once you get it working, then copy and paste that code inside, or just indent it and put define function, and put that code block inside there, finish it with a return statement, okay? So here's just a dumb little pseudocode example, all right? So there's actually this module in Python called Turtle Graphics, and it's the idea that you have this little, turtle or something, and I should give him a head. Okay, and you give it something like go forward 100 pixels, okay? Then turn left 90 degrees, then go forward 100 pixels, then turn left 90 degrees, go forward 100 pixels, then turn left 90 degrees, and then, or I'm sorry, whatever I said, okay? And then, basically finish off the square and turn back another 90 degrees or something like that. We could create a function to encapsulate these lines of code. And so my advice is just start writing this in your global environment, and you get it to work and you go, okay, yeah, that's what we want it to do. Can I do this inside a function? And so we could just say, hey, you know what? Really all we needed to do was go forward, turn left 90, and when I want to encapsulate that in a for loop. Okay, so I'll say for I in range 4, that's going to be for I is 0, 1, 2, and 3, so we're going to repeat it 4 times. Even though it says for I in range 4, I don't actually have to include I anywhere inside my code. it's just going to first execute it when I is 0. Once it's done, it runs it for I equal to 1, I equal to 2, I equal to 3. It doesn't really care if it uses I ever. Okay, and then we'll call this function draw a square. Okay, if we wanted to, we can start to generalize by replacing any of these values with variables, and we can use those variables as arguments coming into the function, so that when you call the function, you can change it. So here I could just slightly modify this function and say, hey, you know what? Rather than always having to draw one side that's 100 pixels long, we'll just put in length. So maybe I want to draw a side that's only 50 pixels, or maybe I want to draw a side that's 300 pixels long. We can do that, okay? And then here we can say, okay, the other thing I want to modify is maybe I don't want to just draw squares where I turn 90 degrees. Maybe I want to go draw pentagons or hexagons, okay? And so how much do I need to turn? So for a hexagon, okay, we have to go like this, right? And so what was the angle that I had to turn? Okay, well, eventually I'm going to go 360 degrees to face forward. So if I'm going to make 6 turns at the end of the day, this is not. I have to draw a better looking hexagon here. Then the amount we've turned is 60 degrees, okay? So basically, you go through and you say, all right, and then for a pentagon, you do 360 divided by 5, so you're turning 72 degrees. But anyway, so you say, hey, the angle that I want to turn is going to be 360 divided by how many turns I need to make, okay? And so we can generalize this and say, hey, you know what? If you want to have n sides, you're going to do 360 divided by n, and that's going to be the angle, and you'll turn that. So to just generalize, we'll say, hey, if you want to draw a polygon with an angle, n turns and length of each side, then your angle will be 360 over n, and then you'll do this n times for each side. You'll go forward the length, and you'll turn whatever angle that you have. All right, wait. I've only given you one answer. Okay. All right, your second answer is the letter E. E as in elephant. E. E as in elephant. All right, we have to start talking about some of the different data structures in Python. So within base Python, one of the most versatile data structures that we have is the list, and you will use lists a lot, okay? So you just create a list using a square bracket. A list can contain basically any mix of data types. It can contain, you can mix strings and floats and integers, even other lists, even other things in there, okay? Other objects can go into a list. So here I'm going to just create an arbitrary list called fam. We've got names of people, Liz, Emma, Mom, Dad, and these numbers I think represent their heights in meters. So some taller people here. Okay, and we've got that. Here I've got another list called fam2, and notice this is a list of lists. Okay, the top level list has 4 things in it. And each of those 4 things is a list of 2 things. Okay, so the first item within fam2 is a list containing the string Liz and then float 1.73, and then the second thing is a list containing Emma and the string 1.68. We can ask Python, hey, what is this object? Fam is a list of length 8, fam2 is a list of length 4, but each of those 4 things is a list of length 2. You can reference any of the values within a list using square bracket subsetting. You give it the index, and it will give you the thing there. So you do fam square bracket 0, it will give you the 0 index thing, which is the first object within the list. that's going to be the string containing Liz for fam. For fam2, square bracket 0 will be the list of length 2 containing Liz and 1.73. If you wanted to reference, say, Liz within fam2, you would have to say, give me the first object, index 0 position object, and within that, give me the index 0 position object. And then we will get out the Liz from within fam2. You can also use negative integers, and it counts backwards from the end. So fam minus 1 will give us 1.89, right? And fam 2 minus 1 will give us this first, the last item there, okay? So counting backwards, it's not, you don't do negative 0, okay? Negative 0 is not going to give you 1.8, because what is negative 0 is like 0, right? So that should just give you the first thing. So you put a negative 1, okay? And then similarly, if you do fam2 negative 1, that will give you this value 1.89. You can slice a list, okay? So you can get values within the list, and you use this colon operator, and that creates a slice. When you do something like fam 1:3, you can think of this as slicing at the locations of the commas, okay? So you look at the first comma, and you look at the third comma, and you will get back what's in between the first and third commas here, okay? So you can imagine a 0 comma before Liz, and so on and so forth, all right? And so here, slicing between the 1 comma and the third comma, we get that, right? So if you wanted to get from the beginning, you could do like 0 colon or something. So you can imagine that. Okay, so what would 1:2 give us? It'll just give us 1.73. If I just do 1, index 1, there's no colon here. This will give us 1.73 in index 1 position. If I do 1:1, we'll get back an empty list. We're asking slice from the first comma to the first comma. There's nothing to return there. Okay, 0:2 will give us from the 0 comma, which it would be kind of, we imagine it before Liz, and the second comma being between 1.73 and Emma, so that we go from Liz to 1.73. 6 to 8, so 1, 2, 3, 4, 5, 6. 6 starts here. 7, there technically, we imagine an 8 comma, so we'll get dad 1.89 there. 2 colon says go to the second comma and everything after that. Colon 4 says go start from the beginning, go up to the 4th comma, which is going to end at 1.68. So we'll get Liz 1.73, Emma 1.68. Okay. If you say fam colon nothing to the left or right, this will say start at the beginning, go to the end. You'll basically get a copy of the list. Okay, copy of the list. This is a shallow copy, but whatever. Yeah, question.
If we're using like colons to slice, we can put a number like indices that are not like in this, like 6 through 11, for example. You know, our list isn't.
Let's see what happens. Okay, so if I do 6 colon, we'll do that, and if I do 6 through 11, yeah, it doesn't error out. Yeah, so. If you put in nothing, doesn't like that, okay? And you can also put in negative things, all right? So this is counting backwards, right? So 5, negative 5 colon negative 2. So I count back 1, 2, 3, 4, 5, okay? So we'll start at this one, and then down to negative 2, we go to 1.71, so it'll basically give us this, counting backwards. If we have our kind of list of lists, same kind of thing here. 1:3 will give me basically this and this. All right, and then if I do 1:3, square bracket 0, first object there, and then 0:1, then I think we'll get back just Emma, and we get that, okay? A list of that. Lists are mutable, which means we can modify them. So here I've got fam, and I'm going to create, I'll print that out. Then I'm going to assign fam to an object called second. And now we're basically having two names pointing to the same list. So fam points to this list. Second is another name that points to the exact same object. And so here I'm going to change the index 0 from Liz to sister. And I'll say, hey, what does this list second have? And it's going to be sister, 1.73, Emma, 1.68, mom, dad, etc. And then I say, hey, what is fam? Fam is pointing to that same exact object, okay? So even though we didn't modify fam, quote, directly, we did because second and fam are just pointing to the same exact thing. So this is just two names for the same exact object. That's what we have there. If you don't want that, if you want to have a copy, you can create a copy using the colon operator here. So you can say, here's fam. Second is going to be a copy of fam, right? And that's what this is going to do. And so now, when I change the name from Liz to sister in second, the original list fam is unchanged because second is a copy. So here I started with fam, then I created second, which is now an entire copy. I'm changing this, but not the first thing. So that's what we have there, okay? I can also create another copy called using the copy operator, copy method, fam.copy, and we get that, and I can kind of change values in there. Fam remains its original thing. You can also create copies using this, list2, by just taking the existing list fam and saying list of that. And so here list2 has changed, but the original fam has not. So these are all different ways of creating copies of a list. And if you don't do that, we have that. Okay. You can also modify multiple values at the same time in conjunction with slicing. Okay. So here I've got sliced from 1 to 3, 1.73, and Emma. We're going to replace those values with 1.8 and Jenny. Okay. And that works just fine. Okay. All right, we're going to run out of time. These are all, we've seen copy, append, basically just tax things on to the end of the list. So here I've got my list fam. I can append the string me to the end. That's going to just stick it on at the end, okay? So now we get that there. You can also append things by just kind of using the plus operator. So if you have a list and you have another list and you use the plus operator, it's going to just kind of join those two lists together. Now notice here I have to, this is just going to return what that does. If you want to save that, you have to assign it back to say fam here, okay? Whereas over here, I just called fam.append, and that appended it to it. So here we've got this. I could take this existing list, I could append another thing here. We get that. If you try to append, say, a list with a bunch of values in it, okay? Append always appends it as one object there. So now I'm going to get a list with all of these things, and then the last object in the list is the entire list, okay? And if that's not what I wanted, I would have to do something like use the plus operator. So here, if this is fam, and I use the plus operator, then it will concatenate everything together. And so we get Miles, 1.78, Joe, 1.8, so on and so forth. And it's not just one big list at the end. But notice, because I didn't save this result back to fam, fam is the original list with nothing changed there. Okay, I got some stuff here on copies versus deep copies. I'll have to talk about that a little bit later. And then within your homework, I think I said work on this insert and thing. And insert always kind of just tries to put one object in there. So you can only do one thing at a time. If you try to do multiple, you're going to get errors. You can do extend, which will allow you to put in multiple things. But if you wanted to insert multiple things into a position, you can use this last operation, which is assignment in conjunction with slicing. So here I'm doing into the slice 4 colon 4, which is really just that fourth comma, but nothing in there. We're going to assign the values Joe and 2 into that one position there. Okay, we'll go ahead and end here. And let me give you your final view quiz answer.